So I saw, I popped on Twitter just before I got here, and I saw somebody ask the question with the hashtag for ContainerDays, can we stop saying in production already, who isn't already in production with containers? So I have just a couple of questions. Who isn't in production with containers? Okay, I was just curious what the demographic would be like. All right. So let's see. Please take pictures, tweet, troll me, whatever. When people who aren't like officially recording me like pop up and start periscoping me, it just kind of freaks me out a little bit when I notice it. This is my trigger and my problem. I just ask that if you plan to do anything like that, that you give me a heads up. No? We good? Cool. Okay. So you can reach me on Twitter. This is maybe the most important thing. So you can commence trolling now, and you can do it directly toward me. You can email me or find my website if you want to talk to me about anything in particular, this talk or otherwise. That's totally fine. I happen to work for a company named Pivotal. They let me fly around the world and do this and meet people like you, and I'm thankful. So this is my appreciation slide. But now we'll get right to it. So this is not really a talk about containers. So if you came here for a talk on containers, you might be disappointed. This is a talk on operational maturity. And I'm trying to get us all to think about the do's and the don'ts with containers, especially when we're deploying them, often at large scale, often with a decent amount of automation. If we're trying to do any of the modern conventions that are talked about as if they're a panacea for solving all of the world's problems, such as microservices architectures or continuous delivery, or you're trying to either build or use some sort of platform technology, or container orchestration, any of that high-level stuff. What should you do? What shouldn't you do? And this is based on my experience of running containers for about 3 to 3.5 years now in production. So you must be this tall to ride this ride. We're going to be talking about stuff that tends to work well when we're doing a large-scale deployment. And if you're doing a smaller-scale deployment, there's still good practices, but you might be able to skirt some of these rules. It just depends on your context. So just like everything in software engineering, if you ask me a specific question about your specific context, I'm likely to respond with, it depends. But generally speaking, these what I'm going to call best practices have tended to work well for me, and in the environments that I've observed and been a part of. And when I have things that are not good to do, it's usually because I've hurt myself with that before. So that's what we're going to do. So some audience participation. We've all heard of containers. We're here, so that's probably a given. Anyone here using a scheduler or an orchestration tool? It depends on how you like to talk about that thing. Yeah, okay. Anyone here working with the cloud? Can anyone tell me what the cloud is? Not really. Other people's servers, that's the most common one, yeah. So in this case, when we talk about the cloud, I'm just going to be talking about the automatable environment that you deploy your applications to. And this could be in your own data center and managed by cloud-like software, and this could be on providers such as the great Microsoft rHost or Amazon, Google, what have you. This is my Docker slide. Everyone wants to talk about Docker. Maybe not so much these days, but this isn't a vendor talk, so I'm not going to be talking about very specific things for specific technologies unless I point it out explicitly, because there are many ways of running and managing containers, not just this way. And I don't want to sort of tie these ideas to one specific thing, so that's just worth pointing out. The way that we're going to go through this is we're going to go through the 12-factor application methodology, the architectural and design practices that we can employ as software engineers when we're building products in order to make things that will work well in the cloud, but oftentimes we don't pair that up to our operational considerations and how we actually do end up managing and deploying these things. So that's what I'm going to try and do today. Who's heard of the 12-factor app methodology? Those folks? So final couple of questions, I hope. How many people here are developers or engineers building software products? Okay, and then how many people are in operations or IT, trying to keep the lights on, that sort of thing? Fewer people who have to clean up after that first group. Okay, and then how many people have to do everything? So you just don't sleep. These are the insomniacs in the group. Okay, cool. So let's go through these. And I'll try and make it quick. Like I said, I have some bonus material at the end I'd like to get to, and I have until, what, 1:45? So we'll see how we do. So one code base tracked in revision control with many deploys. This concept is the idea that I should not have to change my software. I shouldn't have to commit a revision of any kind or keep a tracking branch of any kind in order to deploy my software to multiple locations. Right? So when we're deploying using containers as a packaging and distribution tool, we have to start thinking about this right off the bat. We think about this idea that we're going to build this package and we're going to deploy it to staging. We're going to deploy it to QA, UAT, production, whatever our environments are. And as a software engineer, I have to think about how I'm going to express runtime specifications or configuration in my code base without making a change to my code base, right? And the same goes for when we take that code base and we package it and distribute it into a new environment. So an anti-pattern, and by the way, I'm using these this false dichotomy of anti-pattern and best practice. Please bear with me. It just makes it easier for the slides, and when people tweet these things, it becomes controversial, so that's kind of fun. Again, there's a continuum, and it depends applies. So one anti-pattern here is building separate images for staging and production. So if you're currently building production-only container with some changes to the code base or specific configuration files that you inject or add to the file system for your container, you're not going to have a good time, because if you do that for the staging environment, you can't deploy that immutable artifact to production anymore. And in fact, you've broken the spirit of the idea of an immutable artifact, the idea that I can actually move the same exact artifact between our environments without making a change to that artifact. Another way of doing this that may be more specific to certain container technologies is the idea of tagging, and using that for things like a dev tag or a prod tag. Semantic versions are definitely the way to go if you're going to use tags, or at least maybe even something that tracks to a specific SHA or change ID in your revision control system. I won't assume everyone is using Git, but I suspect that our code is in Git. So if you translate that into a specific version that's for dev, a specific version that's for prod, a specific version that's for QA, even if you've got this one container, but now we're just using the labels to differentiate them, again, you've broken the spirit, because you can't say with certainty, you can't have what we like to refer to in compliance world, you can't have provenance. You can't understand that exactly what is in dev is absolutely exactly what's going into prod. And this is a critical thing to have as software developers, and I come from an application engineering background before I dove in and tried to solve DevOpsy problems, because I got sick of not being able to deploy anything to production, and I wanted to fix that problem. I would definitely I lost my train of thought, so I guess it doesn't matter. Provenance, yeah, that's what we were talking about. Oh yes, thank you so much. As a software developer, I didn't really think about the importance of that idea, of knowing exactly what's in production and understanding that we didn't make some subtle, unexpected, or hidden change to our code base before we got it into production. I didn't think about it because it didn't really matter to me, but as I got closer to say my VP of IT or VP of operations, and they started to tell me about some of the ways, some of the concerns they have for their job, it started to make more sense for me. If you happen to work for a software provider, whether it's SaaS or maybe you work for an infrastructure company or someone that's providing a service, if you start doing contracts often of a certain size, suddenly there are liabilities in place for whether or not your software works and is secure, has uptime or goes down. And the security part is particularly important, because if you have a breach or a data loss, those liabilities often fall directly on the people who sign the contracts that say we're not going to have that kind of data loss and that kind of breach. So it's important that you can say with certainty that what you tested and what you believe to be secure is the exact thing that you moved into production. And oftentimes it's important because there are some people whose not just their jobs are on the line, but they could be personally fined, or depending on the gravity, they could be jailed. Hopefully none of us have that problem. So a best practice is to use the environment or use feature flags. This one is fairly simple. Again, container technology made this particularly easy for us. I love that 30 years ago, well, I guess only 25, Linux turned 25 this year. So I'll just use Linux, even though I know this goes back further than that. But we used environment variables to change the runtime configuration for applications. We would change the environment the application is running in. The environment could inspect that, or the application could inspect that environment and then move on. And then we made it more complicated, and we added a bunch of XML in there, and then we added, config server stuff, and some of that's important at a larger scale. But then, whenever we started running containers again, we pulled it all the way back, and we were just like, that environment variable idea was pretty easy. Let's just do that. But this one is incumbent on not just engineering and developers, but also the operations folks to understand how to provide runtime configuration. Environment variables work up to a point, and then you need a more sophisticated plan. Who's developing with feature flags right now? A couple of folks? Yeah, so feature flags end up getting you to this next level thing, which is that if you're trying to do continuous delivery and continuously move incremental changes into production, one of the first complaints that you get from almost anyone who hasn't done this before is the idea that, well, I can't just release a feature whenever a developer says a feature is done. And you have to pull back and say, well, that's not what we're talking about here. We're talking about deploying incremental change to software. We're not talking about feature releases. And we should separate those concepts. And feature flags let us do that so that we can move incremental change into production that we believe to be stable and good without necessarily turning it on. Now, of course, the hard part about feature flags is what happens after you flip the feature flag, which is that you have to clean up after yourself, and we often don't get the time to do that. I think I have a question.
Yeah, so contrasting this point to your prior point, would you say to avoid using the environment and or feature flags as a way of differentiating prod from a staging environment?
So the question was, would I avoid using environment variables or feature flags or something along those lines in order to make a differentiation between environments that my application is deployed to? And I would say that I would not, because this is an external mechanism for changing the state of the environment for the runtime of your application. It still allows your container and your application itself that you deploy into those various environments to itself be to be immutable. So it is not changing, but you still need differing runtime characteristics. For example, you're not going to connect a dev environment application instance to your production database. You need a way of making that information known. How do I connect to my database? But you can't do it. You have to do it somehow, and this is the way to do it. Yes?
You're not advocating requiring conditional logic within a container based on the right?
Oh, no. So the question is, I'm not advocating conditional logic based on what's inside. No, I'm not. And we'll get to that in a second, actually. Let me move on.
Isn't there a feature flag?
Sorry?
In essence, isn't there a feature flag, a conditional logic?
I don't want to get into that rabbit hole. The question is a feature flag conditional logic, in essence. Yeah, maybe, but that's a tangent that we're not going to go down. So let's explicitly declare and isolate dependencies. This is number 2. So the idea here is, of course, that we want to have full control and a full understanding of our I guess we call them upstream dependencies, what our software depends on in order to run. This is everything from the libraries in our programming languages and frameworks, all the way down to the operating system and the libraries that run on that operating system. And it's important to make sure they are explicitly declared. We often do focus on that. So most of our environments that we use to make applications, whether you're using gem files in Ruby or upon.xml for dependency management in Java or whatever, we declare them. But I think it's also important to explicitly isolate our application from its dependencies as well. And again, this is a place where containers can make this particularly easy for us. So one anti-pattern here is to use the latest version of things. So is anyone here? No, I don't want to ask that question. Everyone here is using explicit version numbers or version ranges that you know to be compatible with your application, right? Because if you use latest and you're using some 2.0 of a particular library and you go to rebuild, they go to 3.0, break the entire interface, and now your deployment pipeline is broken. Now hopefully with the way that you're managing your applications, you haven't taken your application offline first and have a downtime failure if your continuous delivery breaks. But the best practice here is to declare version numbers of upstream dependencies. You should know everything from that library that you use to parse XML all the way down to the operating system that you're running on. Another best practice here for isolation is to depend on base images for default file systems and runtime. So one of the architectures that I was working on was a polyglot architecture. We had things in production that were written in Java, Python, Perl, JavaScript, static, front ends, Ruby, and we wanted to deploy this architecture into a containerized environment. And the hardest part about this was dealing with upgrades and security patches to underlying operating systems and libraries, and then rolling those changes out to all of those containers that were running our actual application. So what we chose to do is to start with base images. So we happened to use Ubuntu at the time. So we would start with Ubuntu. Now, when Heartbleed or Shellshock came out and we had to roll a quick upgrade to our Ubuntu image, that was a quick thing to do. And we weren't using like certified Docker Hub things because Docker Hub didn't exist, and also it was actually a web security company, so we were way paranoid. We weren't going to do that. So we would roll a new version of that. But then we had all of these runtime containers that were intermediaries. We needed a stable, known good Ruby environment to run Ruby applications. Same thing for the JVM, same thing for Perl environment, Python, and so on. So we had these intermediate containers for our runtime environments as well, so that whenever we needed to change or upgrade Ruby to patch a CVE, we would just roll that container. And of course, we had all this in continuous delivery. So if we rolled a new version of Ubuntu to handle a security thing, then we would trigger a roll of all of the runtime environments on top of the operating system. And now all of our intermediate layers are also automatically being upgraded. And then we had applications on top of that, and they would use as base images the Ruby environment or the Java environment or whatever environment that we needed. And this made it possible for us to manage continuous delivery of our underlying dependencies, which was particularly important for security and keeping things up to date. This is in stark contrast to what I hear a lot of people do with containers, or what they think they're going to do, which is, I'm an engineering team and I'm sick and tired of not getting a good runtime environment from my IT and operations staff, so if we're going to build containers, I'll just do it myself. I'll manage the Docker file in the runtime environment, and it'll be a black box, you don't have to worry about it. I'll give it to you, you run it in production. Has anyone had that conversation? Been on one side or the other? I have done this, so I am guilty of doing this thing too. And it turns out, and I told you before, that sometimes people are personally liable for what goes into production. That doesn't actually work out very well, and that conversation didn't go very well either. But also, that's not how the world works. Nobody that you actually want to work with in IT and operations is going to let you run a black box container in their production environment without knowing what the hell is inside of it and how it's being managed, right? That's never going to happen. Okay, so we should store config in the environment, number 3. These things start to build on top of each other, so we'll be able to go faster sooner. So here's an anti-pattern, config.yaml, injecting a configuration file onto the disk or the isolated file system of a container in order to change its runtime characteristics in a particular environment. This is an anti-pattern because it breaks the concept of immutability. Has anyone, I won't ask you if you've ever done this, but has anyone had the conversation with somebody about container technologies where they say, well, the reason that I want to use containers is they're inherently more portable, and that they're also secure. They're portable and secure. Has anyone heard that about containers? Nobody's heard that about containers. It's working. Okay. So this is a case where we break the concept of portability by breaking the concept of immutability. And every touch point that an application that's running inside of a container has to its host file system, or its host environment rather, every touch point that it has degrades the notion of portability and increases the surface area of that container at runtime, which degrades the possibility of security. That you're less secure with more surface area, and you're less portable with more touch points. So this is definitely a bad move. We could go on, properties.xml, hard-coded feature flags, where we have, and this is what I was going to talk about, which is the idea that we have to make a code change in order to flip a feature flag, where we actually have to go in and commit something and then get it through a release process in order to conditionally change the runtime characteristics of an application. That's a bad move as well. So this one's kind of literally about environment variables. And again, we can get as sophisticated as we want about how we manipulate that environment. We can go all the way up to config servers and that sort of thing. But at a very base level, we want to inject as a dependency or a characteristic into the environment any changes we want to make for running your application in a specific place. Do we have a question?
Yeah, where do you see command line flags? Is that environment variable or feature flag or somewhere?
So the question was, where do I see command line flags? Is that an environment variable or something like that? It is. However, I have never really seen that scale very well. It's really difficult to manage that. If you've got a good hygiene around configuration management, you might be able to manage in an automated way things like upstart scripts or systemd stuff in order to manipulate those. If you're going to manipulate how containers are actually invoked yourself, you can also provide these things with other types of configuration. If you're using something like Kubernetes, you can cram all that stuff in your JSON to describe services. But I would try to avoid personally, as a human being, attempting to manipulate environment variables via command line arguments for larger scale deployments, if that makes any sense. And I wouldn't drop this microphone, but it makes people unhappy, so I just have the emoji for a mic drop. Okay. So we should treat backing services as attached resources. This one tends to trip people up who have existing software that hasn't been built to run in a cloud-like environment, and they're trying to move it into the cloud. And oftentimes, this is where the rubber meets the road on architectural decisions and how much refactoring or changing of our architectural design we have to do in order to make something run well in the cloud. And this is usually the first time that I get people who are a little nervous about it. But here's the anti-pattern that I think is most important for us to remember, is that we just don't have, we should not rely on persistent disk. Persistent disk, especially for state. So if you have an existing application that hasn't been built for the cloud, chances are, it may not be the case, but chances are you use local file systems or local storage. And when I say local storage, that could also be something that's network attached over NFS or Samba or something like that, to try and get some type of networking and clustering effects. But we tend to rely on that. And when we're running in containers, we have a local isolated file system, but it's isolated and ephemeral. There are no guarantees about its longevity or its state. And so we have to take that into consideration. And this is where you can't just pick a container technology off the shelf and deploy it in your production environment and have it solve all your problems automatically. This is often the first factor of the 12 factors that tends to bite software teams hard, because this is where real work has to get done. But this is one that's important enough that I wanted to try and use a technique to try and drive it home, which is that I just made it bigger, and then I made it bigger again. The anti-pattern is assuming local persistent storage for state. So we can't do that. And that's a bummer, because it means a lot of work for an existing application some of the time. That's why I've got that hashtag sorry not sorry down on the bottom. So a best practice is to connect to network attached services using connection info from the environment. Again, these things build on one another. And we can have service discovery tools. And when I say service discovery tools, I don't just mean something like a dynamic DNS solution that allows you to find a service on the network. That's only one aspect, I think, of service discovery, because there's service discovery and then there's actually using the service. And to discover and effectively use the service, you also need information like credentials and authorization information, and perhaps keys, passwords, whatever. But we can get this stuff off of the environment, which, again, is sort of the simplest thing that could possibly work. Okay, this one is something that containers give us for free. Strictly separate build and run stages. And I like this because in order to run a container, you have to go through several distinct phases. You have to build the immutable artifact, and then you have to deploy that immutable artifact into a repository that is as close to production as possible, or even ideally in that environment. And then you can run it, right? So we have this container lifecycle that ends up being respected. Build, deploy, run. And we just do this cycle over and over and over again. In a traditional software setting that doesn't have something so concrete as a container to be built, deployed, and run, we sometimes muddy the waters of each of these phases, and we do them all in one big step. And then we have, and this is how we end up with, install day or deploy day, where we go to try and deploy version 4.0, and it isn't really a deploy day, it's deploy Friday night that might bleed into Saturday and Sunday, and it's a 100-point checklist that 3 people are shackled to their desks to complete until it's actually done. And of course, halfway through, you have the go, no-go meeting to determine whether or not you think it's going well, but you never say no-go because people's political careers are on the line. So it's always just go but be really scared meeting, or go without any sleep meeting, which is always a great way to deploy software. But so I like the idea of separating these stages explicitly, and I think that container technologies allow us to do this particularly effectively. And the reason I like that is because it builds resilience into the deployment process, right? So your path to production should be automated, and it should be composed of several discrete pieces. It shouldn't be doit.sh that you crammed into Jenkins, right? You can't really have reliable deployments and a reliable understanding of what broke in that environment. We need something that's more structured, and thankfully containers give us a few discrete stops along the way that we can check and see if things are going all right, which is good. So the anti-pattern here is install and deploy. Best practice is pretty easy. Build immutable images and then literally just run them. That's what we can do. I did put another thing in the middle there, which is you have to deploy them into the environment somehow, and hopefully put them into a repository of some kind so that they're ready to go and ready to be deployed, ready to be run, rather. It's sort of painfully obvious. This is a really bad joke. Nobody ever laughs at it. Like, here are other painfully obvious things. Anyway.
You gotta own your joke.
Yeah, I gotta own my joke. Yeah, that's true. That's true. I own my typos. So another best practice is to respect that life cycle and really take it seriously. Don't try and make a single step deployment. Make a multi-step deployment that you can invoke with one action. That's the way to go. And again, thankfully, containers give us this framework to make that very easy to conceptualize and then do. All right, execute the app as one or more stateless processes. This is another place where application developers are like, but we have state. What is state? State's information, right? It's data, and we have to manipulate it. We have to use it and store it. And what do you mean stateless applications? Anything that's stateless is just a toy because it doesn't connect to anything, right? And I get that, but what we're trying to do here with applications that are designed to run well in the cloud is to make them resilient and fault tolerant. Make sure that they don't do things, at least not easily, like corrupt or lose information. And so we want to build stateless applications in order to get some of the benefits of running in the cloud. Microservices architectures take advantage of this pretty well with the idea that you've got services that while they manipulate state, they don't manage state internally to a running application process. Right? So in this case with containers, you don't want state to be managed inside of the container. You don't want it to be held inside of the container. You want to get it out of the application running in that isolated environment as quickly as possible. Right? So this is where architectures that invoke things like event sourcing and CQRS, or a message bus, or even an enterprise message bus, like, it's not great, but I take that over not having it. That's where these things come into play, though. And the idea that we should externalize the management of state and transactions that manipulate state to another service that's specifically designed to manage that, not the application we're writing with business logic, right? The business logic workflows shouldn't incorporate the manipulation of state internally to them. So one best practice here is to schedule long-running processes by distributing them across a cluster of physical hardware. And you might ask, why go there? And the reason is because it's as production-like as possible. That state manipulation, and especially applications that manipulate state internally within memory or another ephemeral type environment inside of themselves. We tend to make a mistake as software developers when we have one instance running in our dev machine, and then we deploy to production, and now there are 200 instances, but for some reason our application is misbehaving, and it's misbehaving in strange ways. And what we come to find out is that we use local memory rather than a shared caching mechanism or a key value store or some other thing that's actually distributed on the network. So in our developer environments, we can simulate running on a cluster of hardware by using containers locally, which is pretty helpful. But even, or at least just as important, when you're going through your automated testing and you're spinning up an architecture in a continuous delivery or continuous integration cycle, you should spin that up in multiple environments. And when I say physical hardware, this can be virtualized physical hardware. We want to spin these things up as a collection, as a cluster, because it mimics production. And we want to go to increasingly production-like environments. But one of the nice things with containers is that in a very lightweight way, we can get a fairly realistic idea of network topology in our developer environments as well. It won't be one-to-one, and there are a number of factors for that. Obviously, size of your cluster. My laptop's pretty awesome, but it's no AWS. But we can get close to the simulation of the type of network topology, and that's critically important to avoid state management failures as early in the process as possible. Another anti-pattern here with state management, and this kind of goes back to local disk, is just don't use things like NFS in your large-scale container cluster. If you are doing things on the cloud with containers, especially if you're using higher-level technologies like Kubernetes or a Marathon, Nomad from HashiCorp, whatever it is you want to use. I guess there's Docker Swarm too, that sort of thing. If you're using those technologies and you try to back file system management or state on the file system with things like NFS, you're going to find that the performance is going to degrade and you're going to see failures pretty quickly. Nobody likes NFS and locking, but nobody likes that when you're trying to deploy 10,000 workloads across constantly resizing and reshaping cluster of physical resources that are managing those workloads automatically. It just completely falls down. And this goes back to making good software architecture decisions when you're bringing your applications into the cloud. I don't want to say any more about it because it makes me upset. So incidentally though, the thing that I will say about this is one thing where it's in my experience and to the best of my knowledge, and you may have different knowledge, and I'd be happy to talk about that after the talk, and then I will amend all future talks. I don't want this to be anything about vendors, but in my experience, Google's persistent disk in their Google Cloud Platform actually can manage file system state at a large scale reasonably well. And I don't know about many other environments that do as well as them to the point where it's remarkable enough to point it out. So if you were in the position, hopefully only as an evolutionary step, of not re-architecting your application to avoid things like file system state management, that's a place where you might be able to get away with it. Okay, and if you know of others, we can talk about it afterward. I'm not paid to say that, that's just in my experience. So exporting services via port binding. So when we say services here, that means our application. So when we're managing an application, we're trying to deploy it into containers. One of the first things that we realize is that our hard truths that used to be the way that things always are for the last 30 years are no longer hard truths. For instance, we no longer have port 80 and port 443 available to us only. We have to understand how to make our service available on the network where the container scheduler expects it. And oftentimes they provide us the information about where that port's going to be. Now, thankfully, we can build on what we've already learned, which is we can just get these things from the environment. So here's a good best practice in Ruby. This is Perl. This is Java, if you're into that. Anybody here like Rust? Just ask we got one Rust. Got two Rusts. Just ask the environment for information about the runtime expectations for your application. And then conversely, you should make things like this available on the environment if you're not running your container in a place that makes it available to you automatically. All right, so we should also scale out via the process model, and this is something that we can get away with if we're building stateless applications where the state is managed externally. Then when we want to increase our capacity, we can just run more containers. We can run more instances of that application. So we can horizontally scale applications by adding instances. That's pretty reasonable. And then in order to make this manageable and automated, you need to have the concept of a load balancer, a load balancer that you can manipulate programmatically without downtime. You need to be able to understand how you're going to aggregate logs, analytics, and other information out of the running environment. You can just add more and it should work out. Okay, maximize robustness with fast startup and graceful shutdown. Again, as I said, these things sort of build on top of one another. To build an application that is truly stateless, containerize it in an immutable artifact, and if we're doing that by building, deploying, and then running as the container lifecycle, then we can start up containers in our production environment incredibly quickly. And if we're trying to scale using the process model as well, then when Hacker News finds out about your cool application, all the kids go to it and give it the hug of death. I recently learned that term. I just called it a slash downing. That's what I used to call it. But it's a hug of death. When you get the hug of death and your application's incoming network traffic spikes, you have to be able to handle that. Now, thankfully, it turns out containers tend to start up really quickly. And that's really good. But you can't start up, you can't double your capacity if you don't have the immutable artifact already ready to go in production. And you can't double it automatically if you haven't built a stateless application. So it's important to use what we've already learned in order to get the elasticity, which is one of the benefits of using the cloud and other people's computers in general, is low cost and efficient elasticity in our architecture. And that way we can do fast startup, and we can avoid having our application go down when everybody goes to it because they love it. And we can also increase capacity in order to try to avoid our application going down when someone's trying to be mean to us and actually taking our application down. That is not foolproof, and it is not the only mechanism that you should use in the case of trying to mitigate a DDoS attack, but it is one aspect of that. But graceful shutdown is also just as important, and if you're building stateless applications, that's what that means. That your application doesn't shut down gracefully if you have state being manipulated in an ephemeral environment inside of your application or your application which is isolated in a container. And then that state either gets corrupted or gets lost. Or as your DBAs like to talk about when you're telling them you're going to try going to containers or using any other storage mechanism, that they're going to talk about dropping transactions on the floor. That's a case of not having a graceful shutdown because you have built an application that manipulates or manages that transaction inside of itself rather than offloading it as quickly as possible to another mechanism. So it's important to have fast startup so that we can increase capacity and have elasticity in our architecture, but it's just as important to have graceful shutdown so that we don't lose or corrupt information. So keep development staging and production as similar as possible. This is another thing that containers kind of give us. If we really are adhering to this immutable artifact, this snapshot, this point in time for each of our applications or our services within our architecture, then we can run that same software in our developer environment. So when we know that version 2 of our user service is on production, and that's what we intend to integrate with when we're building a service that depends on it, we can literally run the same exact version 2 that's running in production inside of our developer environment and have reasonable confidence about the compatibility and the contract that we're trying to write our software to. So run containers in development. If you're using a machine where you can use something like Docker Compose to just spin up your underlying architectural dependencies for the service that you're actually working on now, do that using containers. The benefits of that are enormous. Again, we want to be as production-like as possible, even in our developer environment. So you want to simulate network effects and introducing real network interactions in your architecture to understand how that's going to affect the runtime environment for your application. You want to maybe increase the number of instances of either of the application you're actually developing or the applications you depend on, the services you depend on, in order to see what's going to happen in that type of environment. And you can do that very easily by running those containers locally. All right, treating logs as event streams. This one is super important. So the anti-pattern here is don't don't just YOLO shit all over your file system and then try and figure out where it is and how we're going to aggregate it later. Like, we massively overcomplicated log for everything, unfortunately, and that worked for a while, but it's incredibly expensive to maintain and manage that. If you don't have a system that provides you continuous feedback by being able to get information about how your application is behaving in production, then you're running blind. You don't have actionable intelligence, so it's important to get that. And if, when you want to track a new user workflow, you just, open up a new access to a file somewhere, and then you have to mount that, the location for those logs into your containers all over the place, and then you have 1,000 hosts that are running containers that just have application logs strewn all over this one directory. Then you have to find something to go and clean all that up and hopefully forward it along to some, log analysis tool. That's a lot of work. Worst case scenario, and I hope nobody's doing this, you have to actually connect to and log into those machines in production and try and find those logs. And if any of you are SSHing into production right now, today is that last day that you will ever do that. I am confident that everyone here will never, ever, ever personally access your production environment ever again, because you are going to ensure, or work with the teams that need to ensure, that you can get actionable and meaningful information out of your system that it is provided to you, rather than you going in and having to search for it. Because this is like Schrodinger's DevOps, right? It's like if you touch the system, if you look at it, then you've changed it, right? And now you have special snowflakes, and now you have to blow the world away. It's no good. Best practice, just fucking use standard out. Standard out. All right. I don't think I got to my bonus material. I'm sad about that, but hopefully this is all right. If you want to stick around, I can burn through it too. So running admin and management tasks as one-off processes. This is my favorite one. So like, who else here has written doit.sh and then handed it to an admin who has access to util01.prod, and they upload it to there, and then they run doit.sh hoping that some manipulation of the system works out well, okay? And then sometimes we codify that by putting it into some chef recipes. But basically it's still doit.sh. And in a containerized environment, I have seen people, and hopefully you all will avoid this or have avoided this too, that are like, well, all we run in production now are containers, so what I'm going to do is I'm going to containerize doit.sh. And then I'm going to run it as a short-running task inside of its own special container, and now we have this new thing to manage. And the thing is that doit.sh is often actually some task to manipulate the state of your system. This could be anything from like a migration of a schema for your data, which is a pretty common one to do. It could be manipulating something else that's often a one-off task, and you shouldn't do that as a separate thing. We have software development practices for a reason. So the anti-pattern here is definitely custom containers for tasks. This gives you a new thing to manage, a new software delivery lifecycle to manage. It's a huge amount of overhead, even though it just seems like emailing doit.sh to some admin. So the best practice here is to reuse application images with specific entry points for tasks. Oftentimes what we really have is some make target or rake target or a Maven task that can actually be incorporated into the software that it's meant to manipulate and can go through your typical software delivery mechanism to get, hopefully, code reviewing, testing, and eventual removal when it's no longer needed. And then it can be part of your application, which means when you build the container for your application, you now have that task ingrained inside of it. And thankfully with containers, we often have a default run command, but we can also provide alternate commands. Like rather than just running the web server, run this rake task, and that's okay. So I advocate for this because it adheres to the software delivery lifecycle that you already have and forces us down the path of using those responsible software delivery tools in order to get everything to production, even the things we're only going to run one time. There are other factors that are not part of 12-factor that are important that we have to think about that are beyond the scope of 45 minutes for me as well. We need to think about the software design and the interfaces that we're going to expose as part of our services. This is a bigger picture than just containers, but it's also about exposing things like health metrics so that we understand whether or not our application thinks it's healthy, right? So this is predicated a lot on what Google has learned with their SRE tactics, and if you haven't read the Google SRE book, please go read it. We have to manage secrets, which is a very high-level concern, something that we really have to deal with. So when we talk about, oh, just pass environment variables around, we actually have to think about things like, well, actually pass a bunch of encrypted environment variables around, and how do we manage that? And it turns out that there are tools like Vault from HashiCorp, which make that very easy to do and manage. And we have to think about global distribution, which is definitely a whole other topic that's very, very complicated as well. But now you're all cloud native, so good job. But the reason that I'm bringing these best practices and anti-patterns to you, and I hope that they'll be actionable for you, they'll give you some direction whether you're already doing containers or not, just to understand where the pitfalls might be. So hopefully you don't stumble over the same ones that I messed up. But the whole point is repeatability, reliability, and resilience. Right? We want repeatable software, reliable software, and resilient software in the case of potential failures and change. And if we are careful about what we allow ourselves to do, and we avoid doing things that, although they sound fun and clever and in the docs they said you could, if we avoid some of those pitfalls, then we'll actually get more repeatable, more reliable, and more resilient systems that we're deploying. So that's the topic for today. So I had bonus material. I'm going to respect your time, and I know that I think we have to figure out open spaces here soon.
Actually, Casey, they're running over a bit in the other one, so feel free to do
Oh shit, let's do this then.
bonus time.
Okay. So, I'd like to talk about the 5 stages of cloud native. Now that you're all cloud native, it's time to go to therapy. You know these stages, right? Okay. I'm not saying I didn't have fun at the first part of my talk, but this one is near and dear to my heart. So let's dig in. So let's have a seat on the couch, get comfortable. Here's some basic ground rules. We're not going to talk about anything weird, no family history or anything. But I'd like to talk about your delivery pipeline, your architecture, and your automation. Are we cool with that? Everybody's cool. All right, let's do it. Time. Okay. This is what I hear all the time. Deploying my apps to the cloud is painful. This is especially for people who've been deploying their apps to something other than the cloud. And now they're trying to deploy to the cloud, and it turns out that it sucks. It sucks because there are all of these restrictions on us and all of these things that we can't do that we used to be able to get away with. And there are these parameters that we have to live with, and that's terrible. Why is that so hard? So we start with denial. We start with containers are just like tiny virtual machines. And as an IT professional, I already know how to build a golden image. In fact, I have 20 golden images. I'm not sure which one I'm supposed to run whenever you ask for a new server, but I go in and take a look at them, and then, I spin this one up with a new host name, and then I go in and I manipulate, some more information on the actual system, and then I give it to you, right? This is old school IT, and then I deploy it into my, VC or whatever, and elasticity. It's totally automated, super easy. You sent an email, and then I did that thing, and that's automated. But that's not really what containers are. They're not really tiny virtual machines. They're isolated environments or processes to run in, which give us some interesting characteristics within those constraints that allow for something to be lightweight and to have an isolated runtime environment. But that is a far cry from a full-blown virtual machine. This is about running processes in an isolated manner, not running server instances in an isolated manner. Or we don't need to automate continuous delivery. This is another one we hear about. I'm getting a phone call that I'm going to ignore. We don't need to automate continuous delivery. So it turns out that deploying our software is really challenging, and making changes to our production environment right now is really challenging. In fact, it breaks at least half of the time. And because it's so fraught with error, there's no need to automate our deployment process because it's broken now, and we're doing it as human beings who are really intelligent. And it keeps breaking, so why would we automate a process that's broken? In fact, let's not automate that process until we get it into a repeatably solid state. Right? I've actually had that conversation with release engineer, and in a second I'll tell you how it went. Anger. Works on my machine. All right, admit it. Who said this? Who said this when it's not working in production? Yeah. I'm going to give you some advice. So I've been in this meeting enough times that at one point, this is real, I handed my laptop to the guy running the system in production, and I said, it's working here. I can make it run. I can make it run repeatably. Apparently you don't know how. Please deploy my laptop to production. Right? It's got gig E. got 16 gigs of RAM. And by the way, in my performance test, it's running faster than the system's running in production. Now, so why don't we just run it on my laptop? Spoiler alert, that did not work. But this is something that we hear a lot. And when we get back to containers, you'll notice that I talked a lot about developers need to do this, and then operations need to do something that's part of that effort in order to operationalize the 12-factor model. That we have to build applications that don't rely on persistent local storage because we don't have that in our production environment, so we need to work together to do that. And Works on My Machine is one of the biggest reasons why application development teams push so hard, in my experience, push so hard for running containers in production, is because they're tired of their IT and operations team not giving them a good environment to run applications in. It's always breaking, it's never consistent, it's not reliable, it's not repeatable, and it's certainly not resilient, right? And so we say, well, what we'll do is we'll build that environment, we'll build that container, and then you deploy it into production. And that, unfortunately, never really works out. In fact, this gets even worse, and the reason that it never really works out is because then we're using containers as a proxy for avoiding the cultural problems in our organization, right? Because the hardest problem in software is people, which is annoying. And we often try to use these technologies to avoid working together even more, but that's not actually how it works. So when it's not working in production and you have that meeting, as a developer, if you're not like me and you don't just say, run my laptop in production, then you probably say, well, you know what, I think I could figure it out. I'm sorry that you can't. I think I can figure it out. Just give me access to prod. I'll go in there and take a look. Maybe do some live code tweaks and restart some things, and I'll figure it out. I'll figure out where the logs are in the file system and we'll make it work. And of course, then your IT team says, well, everything you've given me is terrible and keeps setting my servers on fire, and now you want more access. Sure, yeah, I'll totally do that. Sounds like a great idea. And that never works out either, right? And you know what? They're right. They're right. But we can use things like containers and repeatable deployments, where we're working together between dev and ops, between your engineering teams and your operations teams, in order to get things that don't just work on my machine, but they work on production as well. We'll also get angry, but that's just YOLOing shit into production. So we built these containers because we wanted full control of our destiny, and then we're just going to deploy them to production without talking to anybody else. In fact, we'll take responsibility for that. We don't need IT and operations, we don't need release engineering, we don't need QA, we're just going to YOLO this out to production. That works great. Except that, as I said before, your VP of IT has signed contracts that says that he goes to jail if you have a security breach, and he doesn't know what you're running in production anymore, so he's never going to let that happen. Or she. Probably she. She's smarter. Bargaining. Okay, so we crammed this monolith into a container, and then we called it a microservice. So we have this application that we're not willing to redesign, that has all of these touch points to the local system, which makes it unportable, that has all of these interfaces that are opened up, which increases the attack surface area for security issues. But we managed to cram it into a container, and with enough command line arguments, we're able to make this thing run in a Docker container, right? Good, we're done. Cloud native. No, you're barely at the starting line. Cloud native. But this is the bargaining chip that we do as well. Another one is bimodal IT. Frankly, I'm not even going to get into this because it pisses me off. This idea that there's a good modern way of developing and delivering software, and that's, I think mode 1, and then mode 2 is the old busted shitty way. And the thing is, I get it. You have an application that's hard to deliver now. Moving it to the cloud and using all of the modern techniques and processes to deliver that software and manage it in production is going to be a challenge. So we'll maintain the status quo. And that's fine, unless maintaining the status quo is killing your organization because you're ineffective and unable to deliver that software. And if it matters to change that software, change it effectively and reliably, then you can't use this bimodal thing to hide behind it's old and slow and hard if you need to make it new and good and fast. So just don't use this as an excuse for being bad. Okay, I'll go really quickly. So what if we create a microservice, but then they all talk to the same data source? So what we're going to do is separate the business processes into separate services, but the data is all in one huge monolithic massive data lake. And we're just going to allow all of those applications to directly touch and probably manipulate that data because that's easier. And now we have microservices. No, you don't. You have Hydra services. You've got this one enormous thing with a bunch of different heads that aren't talking to each other and probably eating each other alive. And they're all corrupting and manipulating the concept of what that information means. And you don't have any true isolation, and you don't have microservices if you can't isolate each service and allow them to be independent by having loose coupling. It's incredibly tightly coupled to have everything talking to the same data store. And you need loose coupling by separating those data stores. It's incredibly challenging, but super important. I don't know where my slides went. Oh, I do know. There's a button. Depression, yeah, all right, so now we're depressed. Let's keep going. So we made 200 microservices and we forgot to set up Jenkins because we didn't believe in continuous delivery before. And even though it was the worst day of our lives to deploy that one monolithic application, now we have 200 of them to deploy, which means that we've increased our problem by what, 20x? So this is something that is to be avoided and will cause depression. Automate your path to production. If you're going to go into a services-oriented architecture of any kind, anytime you build a new thing, the first successful outcome, the first product of that new service should be its automated deployment path to production. So that you don't get to the end of your MVP cycle in 3 to 6 months and where you're ready to go to production, but you've never done it before. So now you have another 3 months of negotiating with a bunch of people who don't want to give you any resources or access or environments to run your application. And now you're 3 months behind and everybody's blaming each other. You said you wanted 5 servers, but you actually need 10. Well, you should have known, or you should have gotten to a place where when you were done with the MVP and you thought you were ready to make the service available, you should have already had it running on 10 servers at that point. Right? So automate your path to production, critically important. Or we have an automated build pipeline, but because business doesn't trust us to actually deliver software, we only release twice a year. Because every time we release now, it's a tire fire. So they don't want to do that very often, because that sucks, that hurts, right? And this is why repeatable continuous delivery with automated builds and trusting the container lifecycle that we talked about before is so important so that you can get to consistent incremental software delivery and you can avoid the business squashing your ability to deliver that all the way into production. Because risk in any software, in any software system is undelivered code. Because undelivered code is information that you don't have. It's a feedback loop that has not been completed. So if you only release twice a year, you've got a bunch of theoretically completed work that's hopefully going in the right direction, but no actual feedback to make that clear whether or not you did the right thing or you're on the right path or if you're in a bad direction. So make sure that you do the work to allow the business to believe in continuous delivery. Because if they squash that, then you're not increasing throughput at all. And even if you try to increase throughput out of software engineering, you're making your problems harder because you're only increasing risk by having undelivered code. Software sucks. Acceptance. So good job, everybody. This is our fault. Every software and every system has problems. That's what I really mean. We have to respect the CAP theorem in distributed systems. We have to respect Conway's law, which is distributed systems for human beings. And also, small batch sizes work for replatforming software too. So if you're trying to move your software into the cloud, you can make those incremental steps of cramming your monolith into a container. But know that that's only one incremental step, and it's very early in the process, and you have to keep going. Automate everything. Time's up. What have we learned? We need to have a good architecture. We need to have a good culture. We have to have continuous delivery, and we have to pick all three. This isn't a pick two situation. All right. Thank you for indulging my extra time. I'm Casey West. Thank you very much.